Hello, I'm going to be doing a quick video on Redox. Well, I hope it's quick. It might not be quick at all because there's quite a lot in Redox. So first of all, let's talk about oil rigs. Not the ones in the North Sea, but the ones in Redox. Oil rig is an acronym. You see, that it stands for oxidation is loss, reduction is gain. And it's obviously talking about electrons, because it's all about electrons in chemistry. And a redox reaction is where both these things happen simultaneously, hence the name. Now there are some terms which you will need to remember, such as an oxidizing agent, which gets reduced because it oxidizes another thing. That's why it's an agent. And likewise, a reducing agent is similar in that it reduces another and gets oxidized. Now, instead of thinking about it as loss of electrons, gain of electrons, you can think about it in terms of oxidation number or oxidation state, where the oxidation number is the hypothetical charge of that species if it is kind of ionic and removed from the thing. You'll get what I mean later when we actually do some examples of this. So redox, well, can also mean a reduction or a decrease in the oxidation number, or an oxidation would mean an increase in oxidation number. Some things you need to know is that the oxidation number of an element is always 0. Even a diatomic elemental thing, as long as there's only one thing in there, like Cl2 or argon, nil. 0, nada. Okay? Very important. And the oxidation number of an atom in an atom of a compound, such as, say, let's get a pen out, say like, hello, SO4 2-, this and this, that depends on the overall charge and depends on the oxidation numbers of all the other, well, it's just atoms really, not ions, in the actual compound. And the most electronegative constituent atom has generally the negative charge. So there is also a table which shows the oxidation states of common things. So you see oxygen is 2-, unless you're peroxides, it's 2-. Just remember that. Hydrogen is H+, so that's 1+, unless it's in hydrides such as this, where the Na gets the plus and the H gets the minus. Halides are generally 1-, though it kind of breaks the pattern as you go down to like iodine especially, just completely screws it. Bromide kind of does, and chlorine can become Cl plus in HClO, where this is plus, this is 2-, so this must be plus, because this is 0. And in metals, you check the Roman numerals usually, or that's the one they'll ask you to work out. So, and as I've mentioned before, the sum of all the oxidation numbers must equal the overall charge, such as S in SO4 2-. Funny how I put this here. Shall we work this out? Well, the S, well, we know the oxygen is 2- each. 4 of them, right? 4 times 2 is 8. Okay, I'm not going to be that condescending with the maths. So 8-, and you want 2- overall. So the S must make up the rest. So the S must be 6+, because, well, 6 minus 8 is -2, and that gets to this. Next one, so the S is 6+. Iron in Fe2O3. In iron oxide. So again, the oxygen is 2-, so that's 6- total. So the iron must be 3+ to make this 0, because this is a 0 charge. So it's iron 3 oxide. And then we have S in H2S. Now the S here is different from the S here, because we've got a hydrogen, and the hydrogen is plus, so in total that's 2+. That means the S must be 2- to make this a neutral molecule. So it's 2-. Sorry. 2-. Okay? So that's how you find the numbers of certain things. You use the known ones and the ones it tells you. So like, if it tells you like manganese, 2 dioxide or whatever, manganese 2 oxide, vanadium 5. Whoa, that's just 2 V's. Bruh, that's whack. Next, anyway, with redox equations, you have half equations. which half equations show either oxidation or reduction. It shows the movement of electrons. And to construct half equations, first of all, you need what you're getting from, such as Cl2, and what you're getting to, such as Cl minus. This is an example, going to be an example later. And to construct it and balance it, you can only add three things: electrons, water, and protons, or H+. Generally in that order. You need the electrons for the charges to balance out the overall charge on either side. You need the water to balance out any outstanding oxygens which may have peeled off. And then you need the H+ to balance out whatever H is added on the water. And if you do those in that order, you'll generally get the right charges first or second time if you mess up. Right, so we have some questions. Magnesium burns in oxygen in a redox reaction to form magnesium oxide. Well, magnesium, we know magnesium. Magnesium's 2 plus O2. So if we say 2 magnesium plus O2 makes 2MgO. Yep, there we go. I think that's it. Construct two half equations showing this reaction. So if we look at the oxidations, magnesium goes from a 0 to a 2 plus. Oxygen goes from a 0 to a 2 minus, because remember, elements are 0. So if you want the half equations for this, oxygen is reduced because the oxidation number goes down, it gains electrons. So O2, I probably don't have enough space here judging by the slide. O2 goes to 2O2 minus, because if it was taken out, it would be a 2 minus, right? So now we need electrons to balance this out. There are essentially, it's gained from 0, it's gone to a total of 4 minus here because there's 2 of these, so you need 4 electrons gained. So that's these, and no water is needed, and no H+ is needed. So that's this half equation. For the magnesium, if oxygen gets reduced, magnesium gets oxidized, because magnesium is a reducing agent, and hence oxygen is the oxidizing agent. And you wonder why it's called oxidation. So for magnesium, you go from Mg to Mg2+, which is the loss of 2 electrons. So you need 2 electrons on this side to represent that. Okay, cool. Let's try another one. Aluminium reacts with chlorine to form aluminium chloride. So aluminium, first of all, gets oxidized into 3+, goes to Al3+, because that's the only one it goes to, basically. And therefore it loses 3 electrons. Chlorine goes from chlorine elemental to Cl minus, because that's the only one, again, that it can go to, except for certain cases like HClO, but that's not what's happening here. So if it's 2Cl minus, that means it's gaining 2 electrons plus 2E minus. Now, what you can do is you can combine these and cancel out the electrons to get a balanced equation. So since this one has 3 electrons, if we do 2 lots of that, this will have 6 electrons. And if we do 3 lots of that, it'll have 6 electrons on the other side. So this 2 becomes 6 because 2 times 3 is 6. And so if you add them together, 2Al plus 3Cl2 makes, and these two will come together to form a compound. So 2Al, hold on. No, this will come together to form Al2 Cl3. What have I done? I've done something pretty wrong. Right, conclusion, I'm a dimwit and an idiot. 2Al plus 3Cl2 obviously goes to 2AlCl3, because I can do maths, I promise. And that is your final full equation by combining half equations in that way. Right, I think after this, full redox equations. The way we're going to do this is I am going to do some exam questions that I found. And you can follow along and look at me as I struggle. I mean, I don't know if I'll struggle. So, the half equation for chlorine acting as an oxidation agent is Cl2 plus 2 minus makes 2Cl minus. Thank you, Mr. President. Very cool. So, A, define the term oxidizing agent in terms of electron movement. Well, an oxidizing agent gets reduced. So, an oxidizing agent accepts electrons from another species, because it needs to talk about electron movement, and is reduced. I think this is it. This is a wordy question. So, B. Indium is a metal that can be oxidized by chlorine. Write a balanced half equation for the oxidation of indium metal to form In3+ ions. So simply, on one side you have In with an oxidation number of 0. After the arrow, you got In3+ with the 3+. So to get from 0 to 3+, you need to lose 3 electrons. You need to have 3 electrons on this side to have a 3- to balance out, because that equals 0 equals 0. Okay, so that's the equation. And C, use the answer to be in the equation above this to form a balanced equation for the reaction of indium and chlorine. Okay, right. This is what we get. We get In makes In3+ plus 3-. Cl2 plus 2E- makes 2Cl-. Like the aluminium one on the previous page, but I'm going to do it correctly first time this time. So you need 2 lots of that to have 6 electrons on one side, and 3 lots of that to have 6 electrons on the other side, so they can cancel. Add them together. 2 In, 2 indiums plus 3 Cl2 makes 2 In Cl3 plus. That's it, because that essentially cancels with that. If you have the same thing on either side, they're not part of the reaction because they're there on both sides. And more exam questions, just one more. This is one I found on Physics and Maths Tutor. It's like the first result or whatever from Google for redox reactions. So, okay, chlorine is formed when potassium manganese something. This annoying, scary looking thing reacts with hydrochloric acid in this rather terrifying looking equation. But don't panic. It's not that bad. Let's look at the questions. For 1 mark, deduce the half equation for the oxidation of chloride ions to chlorine. So, chloride ions to chlorine. 10Cl-, or rather 2Cl- to Cl2, because we want the simplest thing. This is just 5 lots of that. We want the simplest thing, which is just 2Cl- to Cl2. And to get there, that's oxidized, so that loses 2 electrons to make a 0. This is 2-, so you need 2E- here to balance that out. So that all equals. The oxidation state of manganese in the MnO4 ion. Well, O4- rather. Well, okay, let's go to the corner. MnO4-, O is 2-, practically always, so that's 8-, and we want to make 1-, so we need 7+. Math. Deduce the half equation for the reaction of magnesium tetroxide. Ions in acidified solution to magnesium. Manganese 2 ions on water. I keep saying magnesium. It's manganese. It's not magnesium. Magnesium's Mg. Right, so what this is saying is you take this bit, you take the rest of it, and you worry about that bit only. So first of all, let's write down MnO4 minus, because it gives you the full equation, doesn't it? And you can divide by 2 to get a simplest ratio. To Mn2 plus 4H2O plus 16, nope, 8H plus MnO4 minus, and this is a reduction from 7 plus here to 2 plus here. Right, so what you need is you need everything to balance out. So to get from 7 plus to 2 plus, and that goes into that because that gets taken out, you need the electrons, which are, well, it'll be 5e minus, wouldn't it? So that gets the 7 plus down to the 2 plus, and that's the one you really want to worry about. To the electrons, water, hydrogen, H plus. But since it gives you most of these here, you don't quite need to do those. Next, chlorine behaves as an oxidizing agent in the extraction of bromine from seawater. I've never seen this question before, so this is like my first time doing it. In this process, chlorine gases bubble through a solution containing bromide ions. Right. So we get from Cl2 plus Br minus, some amount of Br minus, to Br2 plus Cl minus, because it behaves as an oxidizing agent, so it gets reduced. So from this thing, I will deduce that Cl2 plus 2 Br minus makes bromine plus Cl2 Cl minus. Observation. Well, bromine elemental bromine is a very strong color. So I would think there would be some sort of brown color formed. It might be a brown gas formed. I don't know. This is how I'd answer it if I'm really stuck. Just pick from what I know and BS the rest. In terms of electrons, state the meaning of the term oxidizing agent. We've already done that, so I'm not going to write it again. And finally, C. In sunlight, chlorine can also oxidize water slowly to form oxygen. Write an equation. Oh yeah, give the oxidation state of the chlorine in the species form. So Cl2, we have that, we know that, and it forms oxygen from some amount of water, where 2 minus to 0. I need at least, that would have to be reduced then, because it's an oxidizing agent, plus Cl minus. Right, so we need at least 2 of these to get that. But then we need to balance this out. There's 4H plus, 2Cl minus, 4H plus, but that doesn't quite balance. Doesn't quite balance because there's a, well, it balances. If you check the thing, no, it doesn't quite balance because there's charges on this side, and the charges on this side is a big no-no. We can't have that. So that this side overall will be 2 plus, this side overall will be 0. So the easiest I can see about doing this is just to add another chlorine on, which makes this 4 Cl minus, and yes, this is going from 2 minus to 0. This is going from 0 to minus, and if we do it this way, everything will be balanced, and these can make 4HCl. The oxidation stories of the chlorine the species formed. What is HCl? 1 minus, Cl minus. And that's the end of the video. Hope you remember something from that. I'll see you sometime later when I make another one of these, maybe.